Thank you for using the microphone. Just a quick reminder, if we do have time for questions, please step up to the microphone. Don't ask them from the floor. Otherwise, people listening in online won't be able to hear the question. Our next presentation is titled Comparison of Intra-Roll Subclass Characteristics in Polymer Films, and it will be presented by Daniel Mabel. Mr. Mabel is a forensic scientist in the Trace Evidence Department at the Cuyahoga County Medical Examiner's Office in Cleveland, Ohio. I'm sorry if you're a Browns fan, by the way. He earned a Bachelor of Science in Chemistry from the University of Florida in 2008 and a Master of Science in Forensic Science from Virginia Commonwealth University in 2010. He began working in the Cuyahoga County Medical Examiner's Office in 2011, where he collects, processes, and examines items of trace evidence in various disciplines, including fiber, paint, tape, hair, gunshot primer residue, bloodstain pattern analysis. I'm going to run out of breath going down this list, Dan. He's also a member of numerous professional organizations, including the American Society of Trace Evidence Examiners, where he currently serves as a director as well as the chair of its communications committee. Please welcome Mr. Daniel Mabel.
Thanks. Good morning. Someone was kind enough to point out to me that in the program that I'm referred to as a doctor. I'm not a doctor. That's just my nickname. So, I work at the medical examiner's office in Cleveland, so I encounter plastic bags as evidence in quite a few of the cases that I come across on a daily basis. We see them in a lot of different circumstances, and there's a lot of different types of evidence that can be recovered from a plastic bag. But specifically today, I want to talk mostly about polymer film comparison. There are a large number of class and individualizing characteristics that can be assessed and measured when looking at any type of polymer film product. These are just a few of them. And by doing a comparison of those characteristics, you can come to one of a few conclusions. You could eliminate your question bag as having come from a known roll. You could have a basic class level association, or you could have potentially the gold standard, the physical match. You may also have an inconclusive when your exam is limited by certain outside interfering factors if the bags are damaged or destroyed in some way. But what we were most interested in is a gray area that exists kind of between the class level association and the physical match. What if you don't have a physical match? Is there anything more that you can say beyond just a basic class comparison? So that's what led us to look at these subclass characteristics in the polymer films. This is the AFTI definition of subclass characteristics, that they are produced during the manufacture and they're consistent among items fabricated by the same tool in the same approximate state of wear, meaning probably around the same time. So what these subclass characteristics serve to do is restrict the class by some amount, by some unknown amount. And if you could restrict the overall class, you could potentially increase the strength of an association that you're making. These are a few examples of some of the subclass characteristics that we studied, and I'll go into more detail in a few slides. Overall in this study, we had three goals. The first goal with any manufactured product has got to be to understand that manufacturing process. We had a kind of a cursory knowledge of the manufacture, but by examining them more, we learned a lot more about the evidence that we were looking at. And then phases 2 and 3 were to look at intra-roll and inter-roll stability of these characteristics. So we wanted to look between bag 1 in a roll and the last bag in a roll to see if those characteristics were stable, and then look between rolls to see if we could find any consistency between rolls. This is a very busy slide talking about the polymer film manufacturing process, but what I thought would be more beneficial would be to actually just show 2 videos about this process. So first here, we have the actual manufacture of the polymer film. So polymer beads and pigment are mixed together. They are dropped down into a hopper and fed into a screw. And by a large amount of friction, heat is created and the polymer is melted down into a liquid. That liquid polymer is then extruded up through a die and mandrel, and it becomes a hollow tube. And there's a stream of cool air in that tube that cools the polymer and makes it a solid again. It's then flattened and rolled up onto a series of rollers. And once it's rolled up, it can be translated directly into manufacture of a finished product, or it can be stored for later use. So in this second video, we've fast forwarded now to the actual production of trash bags. The very first thing we're seeing here is that there's a slit being cut in the side of what was once just a cylinder, a polymer tube, and in this case, white drawstring material is being inserted into where that fold was created. The drawstring is then heat sealed and placed. There are other heat seals that are created perpendicular to the machine direction of the bag that create the separation between the bags. There are also perforations made, and once those perforations are made, the bags can then be separated into their individuals, and they can be folded, and then they will be ejected from the machine as separate finished bags and then can be packaged. Obviously, there's a lot of variation in this manufacture process depending on the brand of bag, the type of bag, but this is just one example. Okay, so here's a drawing of, this is like the drawing of a bag that we used in our study. I'm going to be coming back to this drawing a few times during the presentation to highlight the various measurements that we took. And this is how the bags in our study were folded. Again, there's going to be a lot of variation in different types of bags, but I thought it was important to highlight the folding because it'll be important later. For our method, we wanted to keep it very simple. This is just a preliminary study, and we only looked at one type of bag. We looked at hefty, strong, multi-purpose 30-gallon bags. And as a disclaimer, we are not endorsing the use of any one brand of bag for the disposal of human remains. The first part of this was for the basic, just a basic polymer film exam. We had to look at the class characteristics, and we determined that the normal class characteristics were consistent among the whole population of bags. Then we wanted to determine consecutive manufacture. For our bags, they were not actually each separate in the box. They were separated by the manufacturer and then interleaved and rolled up. So we wanted to make sure that they were actually consecutively manufactured, and we were able to determine that through physical matching, fracture matching. We also wanted to look briefly at non-consecutive bags in a roll. We looked at bags that were one away from each other in the roll to make sure that we never had any false positive physical matches. And we looked at those and were not able to acquire any false positive physical matches. This was a description of the different bags that we used in our study. Notably here, rolls 4, 5, and 6 were all from the same lot, and then rolls 7 and 8 were from the same lot. And you can see the number of bags that were in each of those rolls. So now to transition and start looking at some of these characteristics that we observed. We observed a large amount of what I'm calling repeated defects in a roll. This is one example where at the exact same edge of the folded bags that were coming out of this one roll, 12 out of the 17 bags had a pull in the polymer, probably due to an error in the perforator or a misallocation of the pressure. 12 out of 17 bags had this error, and then when we looked at the other rolls, this feature was not present. So that was good. That was something that was allowing us to restrict the class by however much. Then we collected a lot of measurements. I'm not going to highlight all of the different measurements we collected, but I do want to talk about these final two here. So first, we measured the manufactured folds in the bags. I'm just going to highlight the distance here from, the distance from the bottom of the polymer, the bottom of the bag to the first manufactured fold. Here's a photo showing one bag from each of the first 8 rolls. And you can see that there is a wide variation in these fold distances, probably from the actual polymer film hitting the folding mechanism on the belt at a different position. There's a slight variation. The interesting thing here is that for rolls 4, 5, and 6, which are in the middle here, there is a very small variation in this fold width, and that's interesting because those were all from the same lot number. Then also, rolls 7 and 8 were from the same lot number, and there's also a much smaller variation as compared to rolls 1, 2, and 3. The next thing we measured was these drawstring fold widths. This is actually a flap of polymer that when the bag is slit and then the drawstring is, the fold is created to put the drawstring into, we measured that flap. It's actually on the inside of the bag, and we did 2 different measurements, one for the front of the bag and one for the rear portion of the bag. So here in the top table, I have the measurements for all of rolls 1 through 6. There's 113 bags, and the range of measurements here was for the front drawstring fold was this 13.5 millimeters and 9.5 for the rear. So a little bit of a wide range there. But then I looked at the population of each roll individually, and looking at the 17 bag rolls, roll 1 and then 3 through 6, there was only about 2 millimeters of variation within a single roll. And then for a 28 bag roll, roll 2, it went up a little bit to 3 or 4 millimeters. So again, if you had a comparison between a question bag and a known roll, and you were able to take a number of measurements from the known roll, you would potentially create your own little range that hopefully your question bag might fit into. So going back now to the manufacture process, we have the extrusion of the polymer up through the die and mandrel. And what this does is creates a large amount of patterning on the polymer film. The die and mandrel is a machined product. It has manufacturing defects itself. It also has wear and tear that it acquires over time, and all of those features are imparted onto the bag. So there's a lot of conflicting reports about how stable are those bands, the like barcode-like pattern in those bags. One study I saw showed that they showed that the patterns were consistent over a period of 12 months in polymer manufactured over time on the same machine. But then another study tried to actually quantify them using 3D laser scanning and only found a correlation of a couple of centimeters before they changed. So we wanted to look at this. This is roll 2 is a 28 bag roll, and what we did was actually split the bags open, cut the bags open, and display them on the windows of our laboratory to create a light box. And this is actually bag 1 at the top, bag 14, and then bag 28. So these are not consecutively manufactured bags, but you can see that this pattern of extrusion, this like barcode-like pattern, is present throughout the entire roll. So I'm first going to show a close-up of the pattern up here between 1 and 14, and then 14 and 28. So you can see that the bands are traveling through the polymer. And then here's from 14 to 28. A 28 bag roll was good, but we wanted to look at this pattern's change over a longer period. So we went and got a 74 bag roll. This was the longest roll that was made for this type of bag. And grossly, these patterns look very similar. Like it goes from bag 1 to 37 to 74, and the pattern looks like it travels all the way through the bag. And it does, with kind of an exception. So first I'm going to show the close-up of bag 1 to 37. And what I did was align this this kind of wide band here on the right-hand side. And if you see the other striations, like specifically these here, it's the same striations, it's the same pattern, but they've stretched. And what we attributed this to was possibly small or even micro changes in air pressure as that polymer film was being extruded could have caused the expansion or contraction of the polymer and caused these changes in pattern. Now, this doesn't mean that these bags weren't manufactured by the same machine, but it's just something to note. So then here's bag 37 to 74, and again the pattern is slightly shifted, but it's actually contracted back a little bit, and it's just slightly off in this example. Then we wanted to look at different lot numbers, comparing two bags from different rolls, inter-roll comparison. The results here were pretty remarkable. There were drastic differences between the bags of these different lot numbers. We even looked at the bags, one bag from each roll in the same lot. This is rolls 4, 5, and 6. And the patterns are, again, pretty drastically different. We tried to shift the bags and see if we could line up the pattern, and it wasn't possible in this case. The exception to this was rolls 7 and 8. Rolls 7 and 8 were also from the same lot, and by shifting the bags, we were actually able to find an alignment in the pattern. So this is the first and last, This is the first and last bag of roll 7, bag 1, and bag 28, and then the first roll in the first bag in roll 8. I will note that these rolls were not consecutively manufactured because there was no physical match between the last bag and first bag of the two rolls. So in terms of close-ups, these patterns were pretty consistent, and they went all the way through from the beginning of roll 7 to the end, and then from the end of roll 7, there are the striations that travel through to the beginning of roll 8. So there were a lot of things covered, but what we concluded was that these subclass characteristics are pretty stable over a short term. We can't define what that period of time is that it takes for these to change. We don't know how often lots change in the manufacturing process, but they are stable over short term. So the big thing that I want to highlight is that there's a great advantage to obtaining more known samples. If you have a box, or you could figure out what your known is, and you could go and purchase a large amount of these bags, then you could do your own little miniature study on whatever type of bag you have. You could determine these ranges and see then if your question bag fits into this much smaller range than just being able to say that it was the overall class of every bag that was produced just like this. In terms of further study, we want to actually try to coordinate with manufacturers to obtain some polymer that was produced on one machine over a long period of time. And we also want to understand what the lot numbers mean. When do they change the lots, and how does that correspond to our results? We want to expand our study of both intra-roll and inter-roll stability of these subclass characteristics, and look at other bag manufacturers and other types of bags. And then our ultimate goal for all of this would be to try and create a comprehensive exam scheme for this comparison of polymer films, which to our knowledge doesn't exist yet. So that's it. Thank you very much. Appreciate it.